I chose to do my research on the chemical changes in soil throughout the process of decomposition in order to determine Pmi estimation. Pmi can be defined as postmortem interval, which is the time elapsed since death, and this is imperative in establishing a timeline for homicide investigations. Decomposition also does play a very important role in forensic investigation, as the body does begin decomposing 4 minutes after the time of physiological death, which is the time when organ function completely halts. So typically when an Pmi arrives on scene, they take 3 different types of temperature, which is the core temperature, the forehead temperature, and the ambient temperature. And they use typically the core temperature and eyeballing the stage of decomposition to attempt to determine a time of death. As you'll see in this figure 1, you can see the core temperature, forehead temperature, and ambient temperature, and how quickly they tend to cool since the time of death laid out. As you'll see, the core temperature tends to cool a lot more quicker than the forehead temperature, and then the ambient temperature is usually the temperature of the environment in which the body was found. So this research is important because postmortem interval estimations tend to be wide hours and tend to prove either inaccurate or vague. And recently, laboratory-based identification methods of time of death have been moving towards the forefront of forensic research. So using different types of chemical markers potentially could allow it so that the focus is not completely reliant on remains, but more so on the chemistry of the environment as well as the chemistry of the remains rather than the physical look of the remains. So the current method of postmortem interval estimation is using this time of death equation, which is shown on screen. And the time of death equation is time of death equals 98.6 degrees Fahrenheit minus corpse core temperature degrees Fahrenheit over 1.5. And more oftentimes than not, the Pmi does use the corpse core temperature as opposed to the forehead temperature because it's a more accurate measurement of the body's internal temperature. So 98.6 degrees Fahrenheit, breaking down this equation, is the average body temperature of the human body. And then the 1.5 that's shown on the bottom is is an estimation of 1.5 degrees lost per hour since time of death. So there are some errors that scientists have pointed out with this equation. The biggest one being that the body temperature is assumed to be 98.6 degrees Fahrenheit when oftentimes it fluctuates. Most human bodies do range around 98.6 degrees. However, there are some that run cooler, some that run warmer, and it's hard to know what this potential victim's average body temperature was. The other thing is this equation does not take into account the weather conditions, if it was a colder area, hotter area, and it also doesn't take into account if the body had been stored in a hotter environment or a colder environment before being moved to the environment in which it was found. So the aim of this study was to analyze studies focusing on changes in soil chemistry due to cadaver decomposition, and then use these findings to help determine chemical changes in the validity of Pmi estimation. As this was a literature-based study, Wiley Plus Library was accessed, and then the articles were refined using the keywords chemistry, decomposition, and a few others. From here, a variety of articles were found. Some were kept for background information, but 3 key studies were identified, and these studies were then read and analyzed in order to conduct this research. The first study focused on ecological settings pre and post decomposition throughout the entire process of cadaver decomposition. They noted mostly that the nutrient levels tend to increase throughout the process of decomposition. As you can see in figure 2, there was an increase of flying maggot migration as well as fecal matter from insects, scavengers, predators, and grazers. And this whole diagram just demonstrates the differences in the ecological aspect of the environment as the cadaver decomposes, what came, what left. And from this study, they also discovered that the body's decomposition rate is dependent on moisture, not solely, but greatly dependent on it. So if a body is in a thicker, moisture soil, it will tend to have a lower decomposition rate in comparison to a thinner, sandier soil. which there will be a slightly increased rate in comparison to the moisture soil. They also found that the soil over time will become more acidic due to the release of fumes from the body and the release of various bodily fluids and acids. The second study focused on the soil chemistry, specifically as cadavers decompose. They used two different environments, a grave sample environment as well as a control sample environment. And within these two environments, there was a clay, loam, sandy, and organic soil set up. And from here, they found that there was an increase in the chemical levels of the grave samples. However, there was a decrease in almost all chemical levels in the control samples. So as you'll see in the grave samples, specifically calcium carbonate levels did increase, and there was an increase in the organic matter. And there was a slight change in all of the pHs of each level. There was not much change in the nitrogen levels, not any actually in the loam grave sample. This contrasts the change in control species, as there is decreases in every level except for a slight increase in the pH of the loam control. And this is due to the fact that these samples, the cadavers were wrapped in material before being placed into their environments, so there was no room for any outside influence. The final study was focusing on the changes in water versus terrestrial environments. So they compared the differences in soil and water environments, specifically a freshwater and saltwater environment, as well as a fertilized sample, organic sample, sterile sample, and open air sample of soil. So these pig cadavers were placed directly into these environments and checked periodically over the span of 6 months. As you can see in figure 5, this is an example of a couple of the setups used. From this study, they found that there is an increase in acidity levels and nutrient levels in the soil samples. However, the water yielded less nutrients than the other environments. So in this study, focusing on grave soil and control sample soil, there was a significant change in the chemistry, which was similar to what was shown in the terrestrial versus the water ecosystem study. From these, a determination was made that there's a possibility samples could be taken from the surrounding area in which the body was discovered to create an average basis for what is common for that environment before taking measurements of the soil in the area directly where the cadaver was found, to create a basis and try and determine the flux in these chemical markers in comparison to the environment that was not affected by the cadaver decomposition. Clearly, other factors of the environment would need to be considered, and this research does require more in-depth expansion on. But overall, all 3 studies did demonstrate that there would be some change in the soil that could potentially affect the soil chemistry and allow for further markers in Pmi estimation. So some benefits of this study is it can be used at smaller labs that may not necessarily have the equipment that larger metro labs do to be able to pinpoint all soil markers. They may have to resort to using on-scene testing kits for different chemicals, such as calcium carbonate or nitrogen. So this would allow for them to have more access and more ability to use a newer way to determine postmortem interval. And like I said before, this fits for further investigation into this kind of area of forensic research, but also potentially an environmental aspect on the lasting effects of decomposition on an ecosystem. Thank you.